Welcome back, everybody. I appreciate you tuning in. Today we're going to talk about zone boards. Our last two videos we were discovering low voltage shorts that were on a contactor or reversing valve or possibly just in the wire jacket itself. It can really be anywhere. We went through, navigating through a complex set of wires and just homing in on what was, the key components and how to get through that. In that, if you notice, every time we've added a new key component, like a low voltage control, we did experience a low voltage drop. Now, with that, we're going to have to increase those transformers from their VA rating of 40 amps to 75 VA rating. In that scenario, if we were to just keep it at a 40 VA because that's enough to carry the load on the heat pump system, if we were to put a zone system in there, there's more loads. So if you're not going to upgrade the transformer to a stronger volt amp, then you're going to have to introduce that second transformer. We talked about that on our shorts, that when you're dealing with two transformers, it can get a little confusing, and we said that we would actually cover some videos that introduce two transformers. This is going to be one of those videos, so hope this helps you out. Stay tuned. All right, we have a lab here set up where we have our zone board. This is a 3-zone application. We have our transformer, 3 thermostats for each zone, 1, 2, and 3. We have a discharge air temperature sensor. This is known as the DATS. We have 3 dampers, damper 1, 2, and 3. We have our SC640, the meter that we recommend, the field piece meter, where we can show you where we're reading voltage as this thing toggles power on and off. Now, there's no equipment here. We don't have a condenser. We don't have an air handler. So therefore, we're not utilizing blower controls. We're not utilizing compressor contactors. We're not utilizing reversing valves or defrost control boards. We're not utilizing any kind of heater relays for the heat strips. No float switches here, anything like that. This is solely on the loads that we have on this board. So let's go ahead and count those loads. We have 1, 2, 3, 4, 5, 6, 7. We have 7 loads. So this transformer is going to energize all 7 loads, so it can't handle anything else. This is a 40 VA transformer. This is pretty much as close as you're going to get. So we're not going to show you this with an air handler and a condenser in this application, because you're going to not really understand how this stuff works. We're just going to busy it up even more than it's already busy. And if you know my style of teaching, I like to take things, put them together, put them on a table. Let's talk about it. Let's better understand this product, because you're never going to see it this close again. You're not going to see a zone board and thermostats and transformers and dampers within a 2-foot by 2-foot area. It's just not going to happen. And they're going to be all over the attics. These are going to be located inside the air handler. These are going to be all over the house. That's going to be located in your supply plenum. And this is going to be somewhere in a closet or in the vicinity of the air handler, external of that air handler. And so we can take advantage of all of this right here, and we can show you what's going on. Now, there's a lot of confusion when it comes to zone boards. People say a lot of things, and I honestly believe it's everybody's best intentions to say what they know to be accurate. Unfortunately, who we're talking to is the person who's paying the bill. Who we're talking to is the person that has the problem. Who we're talking to is the technician that's junior in the trade that may not be a technician yet. We're training him, and we could be training him wrong. Who we're talking to is our service managers, who can be disappointed when we misdiagnose because we have to go back out because we didn't fix the problem. Who we're talking to are families that depend on their comfort and the reliability of your knowledge. And so it's very important in the timeline to understand how we have evolved with zoning. And where we're at now is present day. So I don't want to take you back, 20 or 30 years ago, which we will cover that in other videos. We're going to cover what can you find today in today's market if you were to go down to your HVAC supplier and purchase something that's, fairly popular and comprehensive. And that's pretty much going to be a Honeywell product. So we have Honeywell thermostats and Honeywell dampers and Honeywell zone board. So we're going to start covering right now in this lab, the fact that, the discharge air temperature sensor is probably the biggest and most important component that I have up here. It's not a load. Okay, it's reading resistance because it's reading temperature. And that resistance changes when that temperature heats up and cools down. So the absence of heat will change the resistance, and this board is going to read that resistance. I've seen people put these in the wrong location, and I've seen mostly them not even being where they need to be at. So let's go ahead and cover just this one sensor here. It's not a load. All right. That thermostat, that sensor, is there in the event that we start closing off dampers, and it's not there to measure static pressure, it's there to read a temperature. That temperature is not to be confused with a coil temperature or the temperature of the vapor line returning back to the compressor. The manufacturer already knows that when that superheat starts to drop, it's because liquid is filling up inside the evaporator coil because we're not removing enough heat. We're not moving enough heat on the coil to boil that off. As liquid starts to move back to the compressor, you lose oil in that compressor. When you lose that oil, you're endangering the compressor's reliability. All right, so these discharge air temperature sensors are there to monitor a limit. And these boards ask you what that limit is. Is it in heat mode? Okay, well, we can't have too high of a limit. Is it in cool mode? We can't have too low of a limit. If we look at a supply air plenum, the standard temperature in the plenum is above 50 degrees. So we know that when that temperature starts to drop into 40s, we're running a very cold coil. If we're running a very cold coil, it's obviously going to start returning liquid back to the compressor. And we're talking a liquid refrigerant. It's an evaporator. So it's supposed to evaporate that refrigerant in a sealed system so we can return in a vapor state, and a healthy vapor state, not a low vapor state. This discharge air temperature sensor typically operates where if the limit drops in the low 40s, it just drops out the condenser unit. It doesn't shut off the indoor blower. It doesn't control any of these dampers. It doesn't tell any of these thermostats that there's a problem, because there is no problem, because it's normal for that temperature to drop. And because it's normal for that temperature to drop, this has to be in play. Now, when you buy a zone board with a kit, typically it comes with the sensor, the board, and the transformer. Now, the reason why they're doing that is because they know they're going to reduce or mitigate those warranty calls, because they provided you the second transformer that's needed. Their 1-800 tech support numbers now not blowing up because somebody didn't install it. The discharge air temperature sensor is now part of that kit, so it can be installed. However, don't think that it's an accessory that is not needed. It is needed. And so this is a very simple process. Just put it where it's supposed to go, wire it where it's supposed to be wired, and it's going to work the way it's supposed to be worked. Now, we will have videos where we actually release zone design so we can understand bypass and supply air dampers and how that air is distributed, and how a air handler that is a high torque single speed blower motor that is with a single stage compressor can still work perfectly fine with no problems on a zone system if the zone system is designed properly and wired correctly. You should have 100% confidence in this. At Ideal Conditions, we are zone experts. This is what we do. This is everything that we do. It's our job to be top at our game. And we want to make sure that that's transparent throughout the industry. There's no secrets to this stuff. There's just the right way. Now, there's no shortcut either. Anything that you speed up and try to get through very quickly, you're obviously going to miss something. So we're going to go through this a very simple, out-of-the-box way. Of course, this is already wired up, but we want to cover in this lab that's already pre-wired. We want to make sure you understand those things that typically get us in trouble because we say the wrong things. So the discharge air temperature sensor, we covered that. if I have a 3-zone control board, can I run it with 2 zones? That would be 2 dampers and 2 thermostats. Absolutely. I don't have to use the 3rd zone. However, if there is the potential opportunity to put a 3rd zone in, then maybe it's good to go ahead and buy the equipment, install it, and in future use, it's now has that capability of installing an additional thermostat and an additional damper. Um, Looking at this, we have a heat pump. We can heat or cool. We have electric heat too, so that means it's 2 stages of heat. Okay. When we look at these thermostats, they're not really fancy. They've been in the industry for a long time. These thermostats are going to control this zone board on a first come, first serve basis. We're going to talk about that. This is some of the confusion. People think that all the zones have to be in one mode. A long time ago, 30 years ago, yeah, the technology wasn't there. Today, reprogram your mindset on this. It can be one zone in heat pump, one zone in cool, and another zone can be completely off. It doesn't matter. If one zone calls for heat and one zone calls for cool, the zone board is there to depict within a fraction of a second which zone called first. And so if I were to try to raise both of my hands up at the same time and we were to slow this down so many frames to see which hand beat it in the race, you'll be able to see that one hand is moving faster than the other, even though my body is controlling it. And so when we look at electricity, when electricity is moving from the thermostat to the zone board and it's relaying the message to bring part of that equipment on, that zone board is seeing which signal came in first. If they're both in the same mode, or all 3 are in the same mode, then they're all going to run. So if they're all in cool, they'll all run. If they're all in heat, they'll all run. When one satisfies, that zone will shut off. But if, say, you have an in-law suite and somebody wants to have that in heat and the rest of the house is in cool, it can sit there and toggle from heat to cool. There is a purge cycle. That purge cycle is there to pretty much make sure that that heat pump outside does not engage, okay, right away. So there's at least a 5-minute time delay, so everything can just power down, pressures can equalize, compressors can come back on through that time delay. In the event there's not additional anti-short cycle protection like boards may introduce or even the thermostat may introduce. So you can sit there and always program a thermostat to not go into a time delay. However, that's not good because you want your equipment to not go from one mode to another mode without taking at least a couple of minutes of a break. So pressures can equalize when that comes back on. Things come back on and things run smoother, and you increase the reliability and durability and longevity of that equipment. This equipment that I have here controls air handlers and condensers. It controls furnaces. It controls all of that. So getting in right into it, all these thermostats are in the off mode. I'm going to go ahead and put the one thermostat fan in the on position. So I'm going to go ahead and just move it from auto to on. And you'll see that our zone board is now going to be relayed that information, and the dampers are going to power down for the zones that are not being ran. So the dampers are normally open, and if you can see here, I've got 2 dampers that are closing. Now the green light is there just to help illustrate, the G-call fan, right? A little funny how to pick a color. But when these dampers start to close, you'll see that one is brighter than the other because we're blocking that light. You can hear a fan running because I do have a fan running here. In our lab, we want you to be able to feel air. So I can actually feel air here. I can't feel it here, and I cannot feel it here. I don't have any air streamers to show you, but you can hear the audible noise. If you look at the zone board, you'll see that we went from 3 green lights with nothing on this left-hand side to now we have a fan light on, right? And on our 3 zone lights, 2 of them are red and 1 is green. So what that means is red, stop, green, go. So when you see red, that means that zone is not being activated. And if we look at those 2 thermostats, it says off and fan in the auto, off, fan in the auto, system off, fan in the on. Now, this zone board will actually relay any voltage coming from the thermostat through the zone board, and it will tell you over here on the left-hand side if you're getting a heating call or a cooling call, if that's a second stage or just a first stage. It'll also tell you what zone called. And so what's interesting about that is I don't have to get my meter out to physically see that. And then these dampers are actually being powered off of the zone board. So when the thermostat is getting a signal for this zone, zone 1, to energize, okay, then the other 2 zones that are not being energized, now the zone board has a job to do, and that job is to now close those zones that were originally open when the system was doing nothing, because we're not supposed to get air in there. Now, some people have said, hey, it's not good to run a fan in the on or auto position. In this situation, you can see that was pretty much harmless. Now, we always recommend that you keep the fan in the auto position just because of negative pressure introducing moisture into the home and raising that humidity will cause uncomfort, especially down here in the southeast. In the situation here, if I were to leave these fans in the on position, for example, I'm going to go ahead and put this fan in the on position, and I'm going to go ahead and put this fan right here in the on position. In a second here, you'll see these 2 turn green. Zone 3 turned green. Zone 2 is about to turn green. Honeywell always makes a popular clicking noise. That's normal. Never be scared if you hear that clicking noise. And now we have these dampers opening up, and now we're just blowing a fan. We're not controlling any type of cooling calls or heating calls. Now I'm going to come over here and I'm going to take 1 zone and I'm going to put my mode in cool mode, and I'm calling for 69 degrees. You can see here that the room temperature is between 73 and 74. Okay, and what we're going to witness here is zone 1 and zone 2 have now shut down, and zone 3 is the only one that is calling. We have a cool call, and the fan is still in the on position. So there goes the second wives' tale, where we were telling people that you cannot have your zones all in fan on, or they all have to be in auto or it won't function correctly. You are witnessing right here in real time that we have 1 zone calling for cool, all right, with the fan in the on position. The other 2 zones, we're not calling for anything but a fan in the on position. But this zone board, because we are in the year 2025, it has already been updated to know that, hey, if I'm getting a cool call, that overrides the demand for just a fan only call. So somebody in that zone, they might say, my fan's in the on position. I'm calling my heating and air conditioning company because, the fan keeps shutting off. Well, the fan's not shutting off. We don't want to drop the temperature in that room, right? The fan's not going to move temperature around. It's just going to, it does. It disperses air, but it does not transfer heat without a coil. And so if we have a problem with dropping the temperature in that zone, it's not because the fan's in the on position. It's because the damper is stuck open. So, and these are just more problems. I'm trying to work out the kinks here. And so if I had, say, this zone here that is dropping the temperature and it's getting super cold in there. Now here you can see that the damper is perfectly fine. It's closed. But if I just looked at that thermostat, okay, and I said, wow, it's calling for fan on, that's the problem. You could easily make a mistake and say, I got a bad thermostat. That's not the case. So because we can't see all this, we want to take advantage and we want to look at our voltage. We want to look at our meter, right? And so we want to be able to understand this zone board and how it's wired up and where my voltage is at. Now remember, I'm only using one transformer, and this transformer is servicing these 3 dampers and these 3 thermostats in this zone board. So that's 7 loads on this. We have nothing going to the equipment. Now if we look at the zone that is calling zone 3, and we look at our zone board, we have zone 1, we have zone 2. Zone 3 is actually over here on this top left corner. And so I'm going to come over here and I'm going to go to common. Okay, I have that wired by blue. And I'm going to come over here to Y1, and I should read 24 volts. And I read 23.7. Now I'm going to try it again with the backlight in case that helps. And I'll try to go back and forth. You can see I got 23.7 volts. All right, so I'm getting a cooling call. Now, if I wanted to check my thermostat, all I have to do is, one, I can come over here and says, well, zone 3 checks out perfectly fine. I'm getting a cool call. It says cool call, and zone 3 is a go. If I look at my thermostat for zone 3, guess what? It's calling for cool. So I'm going to go to my other 2 zones because I cannot visually see my dampers, and I just want to see what's going on over here. So it's not supposed to be running, so I should be getting 24 volts between M1 and M6. If I come between M6 and M1, I have 24 volts. All right, well, it's power close. Okay, spring open. I'm going to come to my other damper, M1 and M6, and I have 23.7. I'll turn that backlight on for you if that helps. Again, I have 23.7 volts. Okay, now I'm going to come over here to M1 and M6 on the one that we know is calling, and you'll read 0 volts on it. That's because it is in the open position. Okay, so far everything checks out. I have 2 red lights. I have 24 volts on the closed terminals. Okay, M1 and M6. All right, so this zone board is doing exactly what it's supposed to be doing. So if I was getting air and I was overcooling in that zone, I'm not going to blame my zone board. I'm not going to blame my thermostat. I'm going to have to go check my damper. And maybe you have a loose wire on that damper. So I'm going to go ahead and show you that if we were to pull one wire off of this damper, okay, the damper will open up. Now I'm not going to get over here and walk around to the damper. I'm just going to simply show you by removing one wire off my zone board. All right, see, I just pulled that one wire off. Okay, so now I don't have 24 volts on that damper anymore. As you saw there, that damper opened up. So if I had a loose wire here or a loose wire over here, that would cause that zone to overcool. So don't go blaming thermostats and go blaming zone boards because you don't quite understand how they work. Just keep watching the video, rewind it as many times as you need to. We got to get through it, and we're going to have more to release. I'm going to go ahead and plug this right back in, and you will see that now we're putting the 24 volts back to the damper, and the damper is closing. Okay. Now, the next thing we're going to do is we're going to cover the common misunderstanding of, can one be in heat and one be in cool? Earlier I said, yes, they can. So we have these 2 zones are off. Okay, zone 1 and zone 2 are off. Zone 3 is calling for cool. Okay, so I'm going to come over here to this top zone, zone 1, and I'm going to come up and I'm going to put the system in heat mode. It's calling for 81 degrees. It's 73 degrees on that stat. Give it a few seconds, and that thermostat will call. Okay, and it just got a heat call. And so we're going to check this here in a second. All right, I'm going to come over and even put my fan in the on or auto position. All right, not that that matters, just to kind of mix it up a little bit. So now I've got one thermostat, fan is calling for fan on, nothing else. I got one thermostat where it's calling for fan on and cool on, and it's open, and it's telling the equipment to come on. And then I have one thermostat that's calling for heat with the fan in the auto. As you can see here, none of my lights on the left-hand side of my panel have changed. That's because this board, it knows that it received the call for zone 1 to come on and heat, but it's not satisfied yet on the zone that's calling for cool, which is zone 3. Okay, and the reason why I'm calling it zone 1, 2, and 3 is because I have in order 1, 2, and then 3. All right, so now we're going to go to zone 1, and I'm going to show you that we are getting the call from the thermostat. So we're going to come over here and we're going to take our lead. We're going to put it on common. And this common, by the way, it's all coming off this transformer. All right, when we get to the smart board, I can better explain that because I can introduce images and whatnot. All right, so I'm going to come down here and show you that I'm getting a G call. Sorry. Common. 23.7 volts. I'm going to put my backlight on there so you can see it that way. There we go, 23.7 volts. Damper's not going to open. Now let's leave my lead on common. I'm going to come over here to Y. I'm getting 23.8 volts. Okay, I'll even come down here to O because it's a heat pump. I should be getting no volts, right? Because it's in heat. I've already programmed it for a O-type reversing valve. Now I'm going to come back over here to the zone 3 that's calling. I'm going to put my lead on common, and I'll show you that I'm getting a G call. We have 23.8 volts. I'm going to come down here to O. You should have 24 volts there. All right, we do. I'll come up here to my Y, and you'll see that I also, let me put that backlight back on for you. And you'll also see that I'm getting 24 volts there as well. And this is telling the zone board, hey, I'm not done yet. Continue to leave my damper open and run my equipment in cool mode. And so when we come down to the equipment section, okay, I can come down here and I can say, all right, well, am I energizing, okay, 24 volts to yellow, green, and O. And we're going to go ahead and check that. Now I have this board wired as a single transformer, so things can function the way I want to in my lab. All right, so I'm going to come down here. I'm just going to put it on common down here. I'm going to show you that I have a Y call, that I have a G call, we got a G call, and I'm going to come down and see and show you that I have an O call. See, I have an O call there. And so the same voltage that I have here between Y, G, and O, I'm getting it here because it's just relaying information from here right down to here. All right, and it's not going to stop relaying that information until that zone right here satisfies in cool mode. The other two zones are off. Therefore, even though I'm getting a heat call, which I've already showed you over here, it's not going to release it. It's not going to release it until that zone is satisfied. So the zone that has the fan in the on position, it shut that damper down because it doesn't have a cooling demand or heating demand because those take a higher priority. The zone that called first by about probably 5 or 6 minutes in cool mode has not satisfied, so that has the priority right now. And so even though I have a heating call on the other zone, it will not release the signal to the equipment and shut this damper down until it is its turn. And it will be its turn the moment we satisfy this thermostat. So how we're going to do that is easily we can just raise the temperature. I'll just kick it up to 74 degrees. That should satisfy it. And this is interesting. We're going to see what happens here. All right, you're going to see that the equipment is going to shut down. Now that's interesting because I'm calling for fan. I'm calling for fan here, but with it off. I'm calling for heat And I can come right here between common, and I'll come down here to my Y so you can see that I'm calling 24 volts. That thermostat is saying, hey, come on. I've got a fan saying, hey, come on and run. A fan saying, hey, come on and run. Okay. The zone board has left off where it was. It says zone 1 is still off, zone 2 is still off, zone 3 is still open, and I'm in purge. This is that time delay that we talked about. Now it does say down here, purge override. If I want yes, I just hit next. So I'm going to go ahead and just skip through this. And now when I do that, you'll see that the lights have changed. You'll also see that my dampers are doing some things. I've got zone 1 that is open, zone 2 that is closed, and zone 3 that is closing. Now let's look at where my thermostats are at. This one's in cool, but it's not calling, right? Because we satisfied it. The zone up here is in heat. It's set for 81. It's not going to satisfy for quite some time. The zone over here, it's in the off mode, but the fan is calling. Again, even though the fan is in the on position, it is not going to allow that zone to heat up. Just like this zone over here that's in cool mode but satisfied, it's not going to allow it to heat up. So now we have had two thermostats in two different modes, cool and heat, and we have seen that this zone board is plenty capable in real time, right, of satisfying first come, first serve. If you look at the lights over here, we have zone 1. It's green. Green means go. Well, that's zone 1. That's zone 1 damper. All right. Zone 2 and zone 3. Okay. Guess what? They're not calling for heat or cool. So they have a red light, red for stop. And then we have a heat 1 and a heat 2 call. And the reason for that is because I'm actually calling for 2 stages of heat. Because I cranked it up to 81 out of 73. Well, that's a good, 8 degrees. Anything over 2 degrees will initiate a second stage if a second stage is available. All right, so what we're going to do now is we're going to go ahead and we're going to put this zone in heat mode. And so I'm going to take this zone and I'm going to go to heat. It's set for 88 out of 73. I'm going to put the fan in auto, not that it matters. Now, if you notice, the system does not go through a purge cycle. All it does is it just opens the zone because they're both in the same mode. All right, it's saying, yeah, you want some heat too? I can give it to you. The equipment's already running. Over here, I'm not going to open up. You want cool mode. There's no way I'm going to open up and let airflow get through here. And this is just a really cool laboratory experiment because, like I said earlier, when can you be at all zones at the same time where the dampers are literally working and you can actually feel airflow and see light, which really helps illustrate open and close too. And so we'll go to the one zone that was calling for cool. It says 74 over 74. Fan in the on position. I'm going to go ahead and put fan in auto. I like to keep them in auto just so when everything does satisfy, we don't want the zone to come on and just run fan only because, like I said earlier, we'll introduce moisture to the home if you're in the southeast due to negative pressure on these homes. Now, we're calling for heat, we're calling for heat, we're calling for cool. I'm going to go ahead and just drop this temperature down to about 70 degrees so we can get a really good cool demand. All right. We'll let that thermostat the thermostat just called. Okay. And so if I go to these two zones on the zone board, you'll notice that I do not have 24 volts on my O terminals because I'm only running the condenser in heat mode. So let's go ahead and look at that for a second. I'm going to go ahead and come up here to common. I'm going to come down here to Y to show you that I'm getting a 24 volt call. I'm going to put my backlight on there. Go back to my Y. I'm getting a 24 volt call. Let me go to my O. I'm getting 24 volts. All right. I'm calling for cool. But guess what? It's not showing me that. So it is literally saying you're not going to run until we're satisfied. Okay. We'll come over here to the other two zones. We'll go to common. And we'll go to Y, you'll see that I'm calling. We'll go to O, you'll see there's nothing there because it's in heat mode. We'll come down here to common and Y. You can see that we're calling. I'll go down to the O, and we're not. So if we come over here to our equipment, between common and Y, you'll see that we're calling for the contactor to pull in. You can see that we're calling for the blower to run. We're calling for the blower to run. And if we go to our O terminal is not getting any voltage for that reversing valve to energize because we are running the compressor only, not the reversing valve in cool mode. So we are in heat mode, first stage heat. All right, so now we're going to go ahead and just satisfy one zone. All right, that one zone, we'll go ahead. Matter of fact, we can go ahead and turn it off. We'll just go ahead and turn that zone off. We have now one zone in heat calling, one zone in cool calling, and one zone off. And the only thing it's going to do is you'll see the zone board respond with a red light, meaning that zone is no longer calling, and you'll see the damper shutting down. Again, the cooling damper will not open up, or the damper getting the cool call will not open up until we have satisfied the zone calling for heat still. So we're going to come over here and we're going to we'll just drop the temperature over here down below 73 in heat mode. That should satisfy that zone, and that will shut that zone down, and then we will re-enter a purge cycle. With that purge cycle, that's the time delay that we were talking about a couple times now. And so basically, we're still calling for zone 2. So zone 1 and zone 3 are off. It's kind of like letting you know that it's in standby mode. Now, you can set your dampers to where they purge open or they purge with no change. I have mine set up with purge no change because if the fan's running, I don't want the people to be uncomfortable in those areas of the home. It's better to have nothing than to have something that you're not going to like. So we'll go over here to the purge, and I'm going to go ahead and hit next. All right, that just bypasses that time delay. And what we'll have is zone 1 and zone 2 off. Zone 3 is calling. You can see the damper correspond. This zone is shutting down like it's supposed to. Our zone that is calling for cool, zone 3, is the only zone that is working. Now, if you look down here, it says 73 Fahrenheit, DATS. That means that the air that is moving through this box and out these dampers is also moving the 73-degree room temperature air across this discharge air temperature sensor. So I'm reading 73 degrees there, 73 degrees on all my thermostats. That goes to show you the accuracy of this. And obviously, the wire's good to go. I'm not picking up any additional resistance. So if I have corroded wires coming from here to here, that's going to change the resistance. That resistance will give me a false temperature reading. If I have a false temperature reading on a discharge air temperature sensor, that is not good. You want to make sure that you have a correct reading. So you can always take your supply plenum and take a thermometer and go right next to it and see if they're within a degree of each other. And if there's a significant difference and you trust your probe, I suggest that you ohm this out. And all you have to do is you can take this out, you can take the two wires, and you can literally take the wires and just go to an ohm temperature chart, and it should tell you, what that value is in temperature to those ohms, both in Celsius and Fahrenheit. We're not going to do that on this lab, but I suggest you do that if you're not getting the right temperature, because the discharge air temperature sensor is vital for these zone systems to work properly, and they get constantly overlooked, and people think that they're not necessary because they don't quite understand what they're there for. So we will cover that a lot in our zoning videos, and we will be releasing a series of videos on zoning because that kind of ties us right from equipment, low voltage side, loads, and it ties right into the next area that we want to focus on, which is airflow. Once we start getting through a lot of our airflow, then we can circle back around to coil technology so we can better understand the heat transfer process and why things need to be squeaky clean. And then we can get right into the meat and potatoes of what everybody wants to know, which is the better understanding of superheats and subcools, which I love talking about that, but I don't want to get into that until it's everything else is better understood. Um, so here we are. We have 2 zones closed, 1 zone open. Lovely experiment here on this lab. I really like this. This is a great learning tool. First time we've done a video on it, so be excited to see how this helps you guys out. And then once we turn everything off or satisfy everything, I'm just going to satisfy the only zone that's calling. You'll see that it will go into a purge mode, okay? And we're going to watch that happen. That'll happen any second now. There we go. Goes through a purge mode. And we can either wait another 3 to 5 minutes. Your time is precious, so we're not going to do that. So we're just going to hit next. Now here's what happens. All the dampers open. If you look here on the left-hand side of my panel, there are no lights. All 3 zones are green, not because they're calling. They're green because they are on standby. They are ready to go. And so I hope that this lab helps illustrate first come, first serve, discharge air temperature sensors, fan being left in the on, fan being left in the auto. Can all my zones be in different modes, whether it's off or on heat, off or on cool, fan on, fan auto? I have debunked anything that you have heard incorrectly right here based on anything that you can walk in and just buy. There's nothing extremely fancy about this stuff. It's just been in the industry for about 30 years, so you don't have to set dip switches anymore. You don't have to put jumpers in there anymore. You don't have to, be confused on, any of the stuff that was, late 90s, early 2000s that weren't very clear. If I had to use a straight cool thermostat or a heat pump thermostat, and with my board, did it have to be heat pump or straight cool? And there's a lot that we went through, and Honeywell's been on top of it, and Honeywell has made sure that we can simply have good, reliable equipment, and good education behind it. And the manuals are excellent too. And hopefully this video helps you out. Now we're going to go ahead and take it to the smart board now, and we're going to draw up these zone boards, and we are going to wire them wire by wire. We're going to better understand our loads on the smart board than we can here, because I can introduce additional controls on the smart board that will have that second transformer control. So stay tuned. Okay, that was very interesting. That lab, we got to see everything we needed to see right there in real time. We got to see dampers opening and close. We got to see thermostats calling and different modes, heat mode and cool mode, fan on, fan auto. We got to read temperatures on the discharge air temperature sensor that was being relayed back to that zone control board. We got to read voltage, and we got to unplug dampers and simulate a power loss to a damper that's powered close only and normally, or spring open, I should say. And we got to see all that, and we got to go over a lot of things that we have heard over the years as zone equipment has evolved to better our comfort needs, where we do not level up on our education, or we're just not trained properly maybe. We got to cover a lot of those things that just are passed on in our industry to our customers and to our tradesmen that are wrong. So we got to fix a lot of that in this video by showing you through transparency, not just talking about it, but physically showing you. That's what that lab was to represent. It wasn't to take his own board and show you how to wire that up. You're not really going to get a whole lot out of it. It's all color coded. I can show you that right behind me on this smart board. And that's what we're going to talk about now. Zone board wiring. All right, I've got a zone board, I got a transformer, and a discharge air temperature sensor. Now this is what we call a kit. Now you can buy a zone board all by itself. This zone board doesn't come with a discharge air temperature sensor. It does not come with a transformer. Or you can buy one that comes in the box like this. And in the box, you'll have a discharge air temperature sensor. You'll have the transformer. And what I'm holding up here is just a 2-zone. Okay. You'll have just a zone board. And all that just fits right in the box. And you can buy it that way. And it's a little bit easier to do that because you have everything that you need. You can just buy these things independently. If you ever walk up to a zone system that does not have a discharge air temperature sensor, you'll see that the purge light will always be blinking. If that purge light is blinking, if you read what that means, it says no discharge air temperature found. That also means that if it's not reading properly, then it's blinking. You need to replace it or replace the wiring going to it. Ohm and out. It's not hard to do that. The purpose of this video is not to really dive in deep on those types of technical problems because we can go through other videos that have that. This is just to familiarize yourself with adding the second transformer past the general understanding of how the zone system is supposed to work, like we showed you in the lab. Getting right into it, I've got the same zone board that a lot of you can find in the field nowadays that involves 3 heat, 2 cool. Very common to see multi-stage equipment. So in our lab, I held up a 3-zone application, which is not good for that. And just a second ago, I held up a 2-zone application, which is not good for multi-stage equipment. If we're dealing with any types of 2-stage condensers, okay, it doesn't matter if it's a variable speed air handler or not, none of that matters. But if we're dealing with 2-stage condensers, we have to have the HZ432. That being said, if we don't have that, then we're not going to be able to get the Y1, Y2 calls that we need when we're calling for 2nd stage or 3rd stage heating. If you're just dealing with like a gas furnace or something like that and you have just 2 stages of cooling, you're not going to need this equipment. You can step it down to a 3-zone. But what confuses a lot of people is they go, well, the terminals are there and I don't know why I need to buy this. Well, truth be told, how many of these versions are they going to print out? So you wind up getting a lot of zone boards that have a lot of the terminals, but just aren't compatible. And you have to program this interface down here to operate on a 2-stage. It actually takes 4 zones. Okay, this is just another misunderstanding. A 4-zone Honeywell zone board, even if you're only working on 2 zones or 3 zones, if you're utilizing 2-stage condenser equipment on a heat pump application. Looking at this here, kind of like how we were on the zone board, everything's just right here at your face. We got the discharge air temperature sensor, we got that transformer, and we have 1, 2, 3, and yes, I put a 4th thermostat on there because we have 4 zones. And if you count 1, 2, 3, 4 dampers. Now we also have an air handler and a condenser here. This air handler and condenser will not be working on this transformer. So this transformer's got a pretty big job. The amount of loads that we have are a lot more than we showed you in the lab. We have 1, 2, 3, 4, 5, 6, 7, 8, 9 loads. 9 loads that transformer is going to be doing a job for. So the transformer that's inside this equipment, it's there to work on the loads that are in the air handler and on the condenser. The transformer here, even though it may be found inside that air handler because we're pulling 240 volts of electricity out of that so we can energize that transformer with L1 and L2, but this 24 volts coming from this transformer is simply there to energize the zone board and then from there energize the thermostats and the dampers. and then it is only going to relay the information on the equipment side from the second transformer. And so I want to try to quickly go through this, but as we start going through this series of videos, so I don't have 1 3-hour video, we're going to start talking more about dual transformers, so there's no confusions if there's a short or anything like this. Now, the fundamentals that I showed you in the other videos on low voltage shorts, it's going to apply the same. All right. I also covered already that in those last videos that thermostats typically don't short out. So, and these zone boards typically don't short out. So we can sit here and go, okay, well that, and that is probably not going to give you a problem. If we look at these dampers, typically they don't short out. So 9 times out of 10, if you have a low voltage short and you have a zone system, it's not really on that second transformer. It's going to be on that primary transformer on the equipment side, right? One of those key components that we covered. And so this is just a quick helpful tip for you to understand that if I'm using dual transformers and I have a low voltage short and I see all this is powered up and energized, but my equipment's not running, don't get confused. You have a second transformer inside that air handler and it probably has a blown fuse, and it's got absolutely nothing to do with any of this. All of this is coming off of this transformer. Everything inside this air handler and condenser is coming off the unit transformer for that. Okay, so do not get them confused. 2 different highways. We're talking about 2 different interstates. Whatever's happening on one has got absolutely nothing to do with what's happening on the other interstates. 2 different things. And you can't not cross commons or 24-volt signals on that. And so what happens a lot is we'll have the transformer here. All right, we'll have 24 volts coming in to, let me find the color, there we go. Let me go ahead and do that again. We'll have 24 volts coming from here over to RH, R and CH are jumped. All right, and then we'll have, let me go ahead and get my other color ready, blue. We'll have give me a second. We'll have blue for common coming back. So I'm going to say this is leaving and this is common returning, and this is the 24 volts from the air handler. Now, everything here on this equipment side, I'm going to go over it first, is to take 24 volts from here and send it back to Y1 or Y2 or G or O. If you notice, I kept on using red because it's all an extension of red. I'm going to go ahead and take that last step out because I don't want to confuse anybody. There is no common going over here. So we're just going to take that back a second. I had RC there and my eye said it's all common. That there is no common here on the equipment side. So we're going to do this again. We have a transformer inside the cabinet, which is R and C. We have 24 volts coming over to the board. All right. This side of the board on the equipment side is relaying 24 volts to all the respected terminals. Okay. And then from there, it's coming out as, so if we have a Y call, we have Y leaving the unit. If we have, let me put a little arrow there. If we have a G call, we have G leaving the unit. Obviously, we know this is contactor, that's fan. If we have an O call, we have O leaving the unit. And what I mean by unit, I'm talking about this unit here, this piece of equipment. And that's all energized from red. Now, this is acting as a relay and is taking the extension of red and it is energizing the terminals that are leaving. So there's one input, 24 volts going in here. Everything else is an output. This is gray. Everything else is a version of blue, light or dark. This is red. They have color coded this. They have tried to make this as simple as possible. This gray block that says equipment only pertains to the air handler and the condenser. I cannot stress this enough. This section here is on its own transformer. It is not shared with this transformer at all. It is taking 24 volts from here, just like you go to a thermostat and it relays everything back out. Well, this is now pretty much a thermostat, right? Except this entire zone board is the thermostat. It's taking all the signals from all the thermostats and it's allowing 24 volts input to be relayed back out based on first come, first served, heat mode, cool mode, fan in the on, damper open, damper closed is going to be coming off the other transformer. It has absolutely nothing to do with the equipment. When they talk about equipment, they're talking about the air handler and the condenser. So if I were to draw arrows, okay, and we said, okay, I have my O wire is going to come over to my condenser, right? And then my common is going to come back to my transformer, right? So there's my path, and that will be my reversing valve. All right, so I'm going to go ahead and put O for O type, right? Like I have O here. Let's go ahead and go to my contactor. I'm going to take Y, and I'm going to come out of here, and guess what? That's going to come over to my condenser. We're going to call that Y. Well, guess what? I got to have a common going back to my transformer, okay? It's going to take the G call from the board, and that's going to come over to the air handler. Remember, we're just pointing arrows again, just like we did on our low voltage short video. And the common's already in here, going right back to my transformer, so I don't need to wire that up. But if I did, it would look pretty much like this, and this would be my G, if you can see that okay. All right, and so that's it. There's nothing else going on other than if I said, oh, what about my W? We'll use purple like I do in all my videos. W is coming out, and guess what? It's coming over here to my air handler, my heat strips, and guess what? Common is coming back, right, to my transformer inside my air handler, and this will be W. That's it. Y-O-W. Any other versions is just a second stage. So do I have a second stage of Y? Okay, fine. I can use black, Y2. It doesn't matter. I don't want to confuse you and you look at this and overcomplicate it. This is only going to my equipment, just like I've drawn it up here. It doesn't have anything to do with dampers. It doesn't have anything to do with these thermostats. It has nothing to do with this transformer. It has nothing to do with that discharge air temperature sensor. All of this here only has something to do with this equipment block. And so we have one input going in, and then whatever's coming in here to say, come on and run, it's taking this all by itself, and it's only staying within, it's only staying within this area, and it's relaying the 24 volts back out, back out, back out, back out, over to the piece of equipment. That's it. So if I had a short going on, all right, this zone board's not going to know anything. I may not receive 24 volts here. That's because I don't have 24 volts leaving my transformer inside my cabinet that the manufacturer supplied for me. The other transformer that we installed in that air handler, well, that's giving me power for my zone board. Now I don't want to wire all this up with my equipment because that's going to make it very confusing. So I want to dumb this down and make this as simple as possible. Let's just quickly talk about the air handler and the condenser and this one section of the zone board that it has nothing to do with anything else on the zone board. That is it. That is it. All right, so I'm going to go ahead and erase that. Okay. And we're going to say, and I don't want to sit here and write R and all these terminals here and G and O and B and W1, W2, all that, because we're going to see that repeated throughout this entire thing. And that's just going to confuse you. So this only has to do with my air handler and my condenser. And it's just taking voltage here, like I said, and it's relaying it back to the corresponding key components that operate those high voltage components. Those loads are my blower motor, my compressor, my reversing valve through contactors, reversing valve coils, and blower relays. Let's see here. Let's go ahead and get right into this second transformer here. This second transformer, it is only for the zone system. Now the reason why is we have to sit here and we have to take 24 volts and we have to make this as an input and then as an output back to the transformer. Okay, we're not going to worry about the L1 and L2 to energize this transformer. It's apparent that that has to happen to step down the voltage to even get to 24 volts. But this secondary transformer is called a secondary transformer because it's not the primary transformer. The primary transformer is in the air handler, and it's not that it's a different transformer, meaning better or worse. It's just primary means it's for the equipment. Secondary means it's for the controls. And so the moment we supply 24 volts here, the first load can energize. That's the zone board itself. This thing will boot up. Okay? So load number 1, transformer powered it. Now, we talked about this equipment section here being energized from the 24 volts from here. So if I were to say, I've got 24 volts coming from my air handler, coming over to my equipment, well, guess what? That is 2 separate transformers. So that means I can't take and put one lead on common here and take my other lead and put it up here and read 24 volts because I'm reading between 2 separate transformers. That is a common problem that we see in misdiagnosing, and people don't understand. I don't understand, I lost my voltage. I don't understand, I lost my voltage. That's because you're on 2 different transformers. If you have dual transformers and you're trying to diagnose the zone board, the thermostats, and the dampers, you cannot take your leads and use this common and go up here. Because if you notice here, I made a mistake at the beginning. I drew a common back. I said, oh, that's common. I made a mistake. There is only 24 volts coming in. All right, so we have 24 volts here, and we have common inside of here, primary transformer. That common does not come over here because it doesn't need to come over here. Just like these thermostats technically don't need a common either, right? Because you can just use batteries. It just needs to relay 24 volts back. All right, so we're going to go ahead and just get rid of this equipment block again. Get all that confusion out of there. Talking about this second transformer here, the secondary transformer, because it's the second transformer for the controls. All right, so basically what's going on is this 24 volts, the moment you put it here, all right, 24 volts will now be right here as an output. Okay? Also, 24 volts will now be over here. Let me go ahead and do that again. As an output. Also, 24 volts, okay, through the zone board will now be here as an output on, and these are thermostats. So we have zone 4, we have zone 1, zone 2, and zone 3. Okay, where else is it going to be? All right, well, it's going to come over to here, and it's going to be on this bottom right corner zone as an output. And so this transformer is sending 24 volts out. Now, where does that 24 volts go? All right, well, let's look at this for a second. We have R, C, R, C, R, C, R, and C. All right, let's go ahead and draw it out. So it's an output here, it's an input here. Output here, it's an input here. Input. There we go. So now our thermostats have 24 volts everywhere. Okay, now this is a path back. All right, So we have our path from the transformer, lighting up the board, and then through the board, it's putting power out on all my thermostats, okay, through my wire and into my back plates, energizing all these the moment I have a common coming back. So let's look at our commons. Common, coming right back. Common, coming right back. Common, coming right back. Common, coming right back. All right. And so we have not completed the path until we can sit here and through the board, go ahead and connect them. The board does that for you. Now check that out. This is what's going on your board. Has absolutely nothing to do with this piece of equipment over here. This transformer has just allowed this board to be energized, and now we have just energized the additional 4 loads. All right, we're getting somewhere. So now that we've done that, we now have other terminals that we can rely on. For example, I have G. Okay. I have W. I've got O. And I'm not going to get into Y2. I don't want to just continue to go into all that. Let's get through this first. If you understand that, we'll get into more serious videos where we get heavily into Y1s and Y2s and all that. We're going to go ahead and put a Y in here. We'll go ahead and put a Y here. Let me go ahead and I'm going to change that color up to a darker yellow so it shows up a little bit better. And I'm just putting it over here so I can stay on the thermostat itself. All right. And so, yeah, you can guess what happens next is through the thermostat, okay, I'm going to take 24 volts and I'm either going to energize it here if I want my fan in the on position. If I want a cooling call, I'm have to run my fan in my condenser. If it's a heat pump and it's an O type, I also have to run 24 volts here, right? Through the thermostat. Well, guess what? You're now going to run, and I'm going to use the color green, orange, and yellow just to spare you some confusion. Let's see here. Let me go ahead and make that green. So now, the moment I have 24 volts here, even though it's wired, this is going to represent power leaving the thermostat to bring that fan on. So if I want this zone to call for cool, this zone 1, then it's going to run my G. It's going to run my Y. And it's going to run my O. All right. And at that point, the moment that happens, this board is now going to release power out with the 24 volts coming in. Okay, so remember I have 24 volts coming from my air handler. Okay, so it's sitting there. It's just sitting there on standby. Well, the moment this board has put 24 volts back on all these other thermostats, you know, if this one zone is the only zone that calls, then now this one zone is taking the 24 volts, and because it called, it's sending power out on whatever demand it needs, like Y, O, and G for a heat pump and cool mode. Well, now it's put 24 volts back into it, so now it will allow this 24 volts over here off this primary transformer to sit there and go, okay, we have a Y call. I need Y out, Oh, I have a G call. G out. Ooh, I have an O call. O out. And that's exactly how it works. And so now, to spare you a little bit of confusion, I'm going to now color these up. There's my O. There's my G. And there's my Y. There you go. And so you see how they have if you look at the path, it has absolutely nothing to do. And so therefore, that zone will be off. Okay? So we're going to say off. We're going to say this one is off. And we're going to say this one is off. Notice I'm writing this on my dampers. Okay? Because the only one, if you look at this, that's calling is right here. Now I'm going to use green because we've been using green on these board for go, green go, red stop. So I'm going to say on. Oops. There's on. Okay? And that's what that would look like. All right? So we have a cool call. The damper is on. Now how is that damper on? Because we don't have any voltage going over to it to tell it to not come on. So where we will have voltage, okay, where we will have voltage, we will have voltage coming from M1 and M6. So I'm now going to put 24 volts here and a common right back because it's off. This one is also off. So I'm going to put 24 volts here on that motor, and then I'm going to give it a path right back. Okay? Because that's the only thing that can shut that damper off is to put 24 volts on it. All right? So it closes because it naturally springs open on these little 2-wire dampers that I'm using. Same thing here. This is off. So my zone board is going to put 24 volts over to my damper, and as long as I have a common coming right back, guess what it's going to do? It's going to energize that motor, and that motor is going to have that damper closed. Well, I don't have red and blue coming over to here, even though it's wired. All right, I don't have any signals coming over to it, so therefore it's naturally in the open position. And that's exactly what is going on. That is exactly what is going on. So we have our equipment that has absolutely nothing to do with it. We know our Y and our O are going over to our condenser. We know our G is going over to the air handler. It's very simple. This is just as simple as a thermostat by itself without a zone system. That's why if you had a customer that says, my zone board's bad, and come out and look at it, and you just go, yeah, your zone board's bad, and these dampers are all messed up. You could sit there and take one thermostat, and I can wire that thermostat right over to here, take that zone board and de-energize my 24 volts, and I can just tie simply this to this and make it happen. And now that will be the only thermostat, and it'll run like it's normal. But, you know, there's not a whole lot more to go through on this without just getting very confusing. Because all I'm going to do is just say, okay, I'm going to do this again, but I'm going to do it here. Okay? But if I did this here and said this is heat, okay, this one's cool, here's what's going to happen. This is exactly what's going to happen. I'm going to have we're saying it's a heat pump. So I'm going to have a G call. So I'm going to receive 24 volts here. I'm going to have a Y call. I'm going to receive 24 volts here on let me put on the right terminal. A Y call right here. But guess what? I'm still going to have 24 volts here, shutting that damper off. And the reason why is because this is not calling yet. All right. And for that to happen, by the way, this would actually have to, through the thermostat, energize here and energize here, right, if the thermostat called. But that's still off, even though this is on. This is on in standby mode. This called first. You witnessed it. Nothing else was calling. It was just that one. So until this is satisfied, that's not going to run. So I'm still going to have 24 volts there. All right, period. No ifs, ands, or buts. And so you just got to understand that signal flow. The discharge air temperature sensor, if I wanted to look at where those are going to go, let's just pick some different colors here. I'm going to say like a pink and purple. One is going to come over to, let's see, where's my DATs? Right here. One is going to come over to here. It is an input, and the other one is going to come in to here. That is also an input. They're both, an extension of these wires, which is why you have to make sure your wire nuts are good to go. You have a good connection, that you're not changing that resistance, because if that ohms changes, then that's going to read a different temperature. So you want to make sure you have good connections. All this wire is a different temperature. I'm sorry, an extension of these wires. Okay, so they're both inputs, so we can read that resistance. So we have a display down here. If that is not hooked up, you will not read a temperature here. That temperature here is based off of that sensor. Discharge air temperature sensor. Okay, what else? I mean, this is pretty much it without getting crazy confusing. Dual transformers. This is simply explained. Look at the path. One has got absolutely nothing to do with the other. Talking about the thermostats and the dampers, why this one still says off, is because we have 24 volts coming over here, because this board realized that one is calling via the wiring, the signal, for heat. The other one is calling for cool via the wiring and the signal, and this one called for cool first, this one called for heat second. These didn't call at all, right? And so it only knows based off the voltage that's coming back to the board. And then all it's going to do is it's going to allow this to relay its power from the primary transformer through its little section here, right, over to the blower relay, the reversing valve coil, or the contactor coil. That's it. This or heater relay if it's a W call. Very simple, nothing complicated about it. This is not to show you exactly how to wire the entire zone board up and how to program it. This is to show you more how this thing works, and then how this thing is wired up in the sense of how does it work, so I can better understand when I'm taking my meter out why it's doing something that it doesn't make sense. And it does make sense. It's just, if you look at things, like that, well, things can look confusing because you don't understand what you're looking at. Somebody more confident is going to look at that and go, okay, I've got 1, 2, 3 contactors, 4 contactors, 5 contactors, a couple other relays here, just a bunch of wires, just going from point A to point B, high voltage and low voltage. Nothing very difficult about it. Look at it again, right? When we were talking about how to find low voltage shorts, we were talking about, you got to understand the signal flow. We were talking about the thermostat and the components, very easy, very easy. And so this going through this, we don't have to get crazy and make this complicated. We should have already, kind of understood a little bit of, dampers are either open or closed based on the thermostat calling. And, as long as you can see the lights here and see what mode this is in and feel airflow, 90% of your zone board and your dampers and your thermostat should be understood. Do I feel air? If that thermostat says cool on, do I feel air? Okay, do I go to my zone board? Do I have a green light for that zone? All right, that's pretty much it. Most of the time on a zone board, you don't have to take out a meter. The times that we do have to take out a meter is when we're trying to depict low voltage short, and what confuses us is not understanding our transformers on this board, where the primary transformer is being fed, and how that has absolutely nothing to do with anything else, because everything else is off the secondary transformer. And that's what I want you to take away from this video. I appreciate all your support. Thank you for watching this channel. It means a lot to me to read your comments as well. I'm not going to leave you stranded. I'm going to keep doing this as many times as possible. I know I took a couple week break. Look, it's busy. It's hot. We got a lot of work to do. My goal is to pass on what I know and try to break it down in a technical sense that's not overcomplicating, but to get you to understand this from a field perspective. And so when I bring that experience into a lab with a piece of technology like I have behind me, I'm able to teach it differently, not your traditional teaching that you see in a HVAC school and whatnot with curriculums and all that stuff. It's just more of, hey, these are common issues that we have in our trade that aren't well understood. There's a lot of things that just hurts my feelings that we just say that are incorrect. And there's one industry. There's no secret to this stuff. So it's our job to pass this information on. And because I care about it, and I care about you guys, because you guys are my brothers out there doing this stuff too, I want to make sure that you know what I know so I can pass this on to you to help you get through this, because I've been there where you are. I know this is not easy and it's not well understood, and hopefully I can simplify that. So please leave me a comment. I'm going to read that. I'll try to get back to you. Some of the videos we've actually put out there because of comments. Share this with others. You got a share button right there. Hit that share, send it to your buddy. Don't try to contain this knowledge so you're the only one that's good in your company. Pass it on to everybody. It's our job to pass on knowledge, whether you know it and you can explain it, or you just know where you found it and you say, hey man, just watch this video. All right, you're helping people out. That's you providing a service to all those customers that you'll never even go to because you shared this with somebody else who can better now understand zoning, and now they're helping out people and you help them out indirectly. That's really cool. Give me a thumbs up. I need that. That supports my algorithm. All right, so I can be found more. And subscribe if you haven't done so already. Stay tuned. Stay safe.